Okay, my name is Jeff Russ, and this is a course on basic concepts of programming. Let's start off with some of the basic elements, computers and programming. Basic elements are data, the noun of computer programs, processing, which is the verb, and input and output, which is how information is shuffled back and forth between the user. So at the base level of everything is the bit, which is just a 1 or 0. The base level of data, even the base level of processing. In order to represent a number or a letter, you need more than one bit. Back in the 70s, the standard was to use 8 bits to represent a character or to represent a number. So that became known as a byte, as in sort of a play on words, to take a byte of bits. So even though we don't have computers that use 8 bits as the standard, it's still a word that we use. Today, we have 64-bit. So whatever platform you're on, a word might be different. So that is basically the smallest unit that most languages address is the word. You can't really access individual bits directly in most programming languages. So the story for us really begins at the word. And with that as our building block, we can represent a number of different things. We can represent an integer, which is a number that doesn't have a fractional component. We can represent a floating point number, which is a number that has a decimal component to it. And we can represent a character, which is a letter of the alphabet. Early computers could only really do integers. They couldn't do floating point numbers, or they were very expensive if they could. So integers go back a bit further. Floating point numbers sort of approximate values. So if you're looking to have an exact value, such as choices 1 through 5, you would use integers and not floating point numbers. That's why we still have integers, and we're not just doing everything in floating point. As subcategories of integers, we have signed integers, which can be positive or negative, and we have unsigned integers, which can only be positive or 0. With an unsigned integer, we're using all of the bits available to represent the number. With a signed integer, one of those bits is being used to represent the sign, whether it's positive or negative. So it has a little less precision than a signed integer, but we're using that additional bit for the sign. Okay, so that pretty much handles data. Well, I should say strings are really just an array of characters put into a container. Early languages like C and even C++ didn't really specifically have a data type called string. They were really just something you assemble yourself. Now, most languages have an actual data type called string. But when you're dealing with C, you pretty much do it yourself. So that handles the data side. With processing, the computer handles mathematics, math operations, logic operations, and read-write operations, which are shuffling around data from RAM to the hard drive, from the hard drive to RAM. Logic is Boolean logic, which is things are either true or they're false, which act as a sort of gate. So you might say if something is true, you execute a certain block of code. If it's false, you execute a different block of code. So it can be used to determine the flow of the program based on that Boolean value of true or false. We could also compare numbers, characters, or strings, and the result of that comparison is a Boolean value that is then used to control the flow or something. And we can also look at something and see whether it exists or not and make a determination of what to do from that. So a lot of languages, the absence of a value means false. So you might check a database to see if something exists, and if it's there, it's true, and if it's not, it's false. So that's the basics of logic, and read-write operations are really handled under the hood. Input and output. Input from the user via keyboard, mouse, touchscreen, and output via the display, speakers, printers. So yeah, those are the basic elements of computer processing and computer data. Now, let's talk about how we go from code to an actual running piece of software. There are several ways. In some languages, they're what's called compiled languages, which means they start off like any other language with words that make more sense to humans, and they end up as a binary for the computer to understand. But when you write the code, you at the end of your process of writing the code, you compile it with what's called a compiler into a file which is not readable by humans, machine binary file, and then that is run by the computer. You have to remember that computers don't know computer language. They don't know programming languages. They only know binary. So languages are just for us. What ends up running on the computer is not a programming language. It's a machine language, which nobody works in because that would be insanity. So that's the way a compiled language handles it. There's a bit more that you have to do before it runs, so it's not really something for executing on the fly. Usually websites are not made with compiled languages. They're made with interpreted languages, which sit as a text file on a computer and execute in real time. So as the program is being asked to run, it's being converted to binary on the fly. So it's slower because it's doing more during runtime. So real workhorse programs, something like Photoshop or Final Cut, they're compiled languages. They could not be interpreted languages. They would be much slower if they were. But things like websites and web apps are interpreted languages, which are much easier to debug. You can change the code as they're running, and you'll see the difference immediately. That's an interpreted language. There's something sort of in between the two, like Java, which is it's compiled, but it's not compiled all the way into machine binary. It's compiled into something called bytecode, which is sort of not machine specific. It would run anywhere, and it runs via another program called a virtual machine. So code is turned into bytecode, which you can't really read, and then it runs in a program called the virtual machine. This makes it a little faster than a pure interpreted language, still a little slower than a compiled language. So those are the three categories. Mostly, if you're in web development, you'll see interpreted languages. Those are really core languages. There are other languages that aren't necessarily programming languages, but they're used in creating a program, such as markup languages like HTML. HTML doesn't do any processing. It really just represents the content of a web page in terms of text and pictures, but it doesn't really do anything to them. So you're marking up text with tags that can be manipulated. So that's a markup language, HTML. Then there's also style sheet languages, which apply style to those markup languages, color, font, things like that. And then there are special purpose or domain-specific languages like JavaScript, which is a real true programming language, but it's meant for web development. It's meant to run in your browser to do processing in real time of a website. Then there are other ones like SQL, which is used for accessing databases, SED and awk, which are used for manipulating data streams, but we won't cover those too much. Okay, lastly, I want to talk about how a program is organized with all these things like data and processing. So, okay, data is in your program typically as variables, which are bits of data that can't be modified. But they could also be constants, which are not allowed to be modified. And in typed languages like C, older languages, these variables and constants are declared with a data type. So you might declare a variable that's an integer, and it's always going to represent an integer and nothing else. Later on, a variable in some languages are able to change their type freely, but in strongly typed languages, they stay what they are. So that's data that's sort of internal to the program, but you might also fetch data from a hard drive or the internet or from the user. So that's another way it can be obtained. But once it's obtained, it's usually saved to a variable to be worked with. Okay, so now for processing, the basic block of code that is used to process data is called a function. Older term for it would be a routine. A function is a set of instructions that are all bundled together into one block of code that can be reused. It can be called whenever you need it to do whatever tasks it does. It takes input and it gives output. It can have multiple inputs. It has what are called arguments. And by the way, these terms come from mathematics, from calculus. So like a calculus function has arguments, and it has a return, which is what it passes out once it's finished doing whatever it does. It might not have a return. Usually languages either have 0 or 1 return. They don't have multiple returns, but you do have multiple arguments coming in. They can also affect data via side effects, which are not things you see being passed in or out, but the function might have direct access to certain variables that are declared to be global so that it can modify them behind the scenes without having to pass things in and out of them. So that's functions. Now, in older languages like C, which are called procedural languages, they didn't really have a way to retain data inside of a function block. What I mean is, once a function finishes its task, whatever data was in it is lost. So it doesn't really hold data, it just processes it. Later on, programming languages became what are called object-oriented, where it had entities that could both do processing and could retain data. So think of like a human. We have memory, we have attributes, and we also have certain actions we can perform. We're not separated into two different things, one that does and one that has. An object is something that both has an internal state that can change, its data can be manipulated, and it can manipulate data outside of itself. And those changes stick, they persist throughout the program. An object might have what's called a class, and a class is like a prototype. It's like to misuse a programming term, it's like a template that an object is created from. So I'm created from the human template. The idea of a human, sort of like genetics, creates me as an object, and I'm an instantiated version of a human. So in object-oriented programming, you would create the definition that a bunch of objects will follow, and then they might have their individual bits of data that are associated with those different objects that come from the same class. So an object has what's called methods, which are really just functions within the context of an object. They have properties, which are sometimes called data members or attributes, and this is the data that they hold. And you can use an object to perform different tasks. Maybe at one time you might have it fetch a piece of data, or you might have it set a piece of data. So it's not just one function it has in it, it has many. So that's the basics, really. We'll start off just with procedural programming. We won't really get into object-oriented programming until later, because it's a bit more complicated. So next up we're going to just talk about the basics of the C language, its data types, and how it works with functions and things, because it's really going to carry through with so many different languages. So we'll do that next, but hopefully that gave you a little bit of background information on how programs work.